So here, what is metal? No. Could you even define what is metal? I mean, basically, I mean, composite, I could understand that you cannot define. So I have already defined what is the composite. Composite is made of the two things, matrix and reinforcement. Matrix are the things which are in bulk form, okay, and reinforcement are which are in less quantity, less amount, okay. So reinforcement is responsible to hold the matrix, right? So these are, I mean, the terms that I hope that you are not aware. So I have already defined. But metal that I mean you are studying since, I mean, school days, right? So metal are composed of one or more metallic elements. Elements I have already made you clear at the beginning. What is the elements? What is the atoms? Okay. So and you all have seen the periodic table, right? The table contained the name that all are the name of elements, right? So metal are composed of one or more metallic atoms. Okay, so atoms are of different kinds. Okay, once you when you will go through the periodic table, you will be able to know that what is metallic element, what the different kind of the elements present in periodic table, right? So these are the examples of metallic elements: iron, aluminum, copper, titanium, gold, nickel. These are the few, right? You will go and you will see, I mean, various, other metallic elements are present in periodic table, right? And often also non-metallic elements. Okay, I mean, metal doesn't mean you have the only the metal present in your metallic compound, right? You could have only metal. You could have the combination of the metal and non-metal as well, right? Okay, these are the non-metals: carbon, nitrogen, and oxygen. These are the non-metals. But though lots of other, non-metals are present in your periodic table, right? But how? If we talk about the metals, then these non-metals would be in relatively small amounts. Got it? It could be present, okay. Sometimes it could not be, okay. But if it is present, then it would be in a very small amount. Okay. So atoms in a metal and their alloys. Okay. So alloys are different things, right? Basically, the combination of two or more, okay, elements, okay, together is known as your alloys, right? So atoms in the metals and their alloys are arranged in a very orderly manner. This is the most important. Okay, so define the metal is not just the combination of or the pure metal of metallic elements. It could be of the metallic element. It could have a non-metallic element as well, but in a very small amount. That's the things. But the most important thing is they would be arranged. The atoms of either the metallic or non-metallic, whatever the elements are present in metal, they all would have the orderly mannered way, right? Very orderly, very fashioned way, right? And are relatively dense in comparison to the ceramics and polymers. Dense means they are present, uh, you know uh, they have the more volume, more material at a very less volume, right? At a very concise space, they are present, in a very high amount, right? So basically, mass means the mass present in anywhere. Okay, at what volume? I mean, if you have concise the volume, if you have taken the volume, how much amount of mass is present? Okay, in that particular volume is known as your volume, your density, right? Suppose if you have kept taken a container like this. Suppose if you have taken a container like this, okay. So here you have put something, okay, and you have you this is your boundary. This is your boundary. So this is I mean it's mean you have defined your volume, right? Now you're putting the gases in which in this particular volume, okay. So if you have 1 kg of gas in this particular container, the density would be high or low as compared to the 2 kg of 2 kg of gases. Same gas. Suppose whatever the gas, hydrogen, oxygen, nitrogen, whatever the gas that you want to take, you can take here. Okay, but the same amount, but in first container, the container have the same capacity. Like suppose you can say 30 mmq, 30 mmq, right? You can take an example. If is 30 mmq of capacity is present, okay, now we have consigned, you have kept the 1 kg of your gas, okay, and the in same container you have kept the 2 kg of your same gas. So which one would be more dense or which would be the less dense? Suppose the container is same, two conditions, okay, here 1 kg, right, here 2 kg. So container is same, okay, gas is same, but you are keeping here you can say it's a one container one, or here you can say the container two. Okay, so
Container 2 will
which
be sorry, container 1 will be heavy, dense,
container
more dense.
dense and container one will more dense or less dense? What you are talking about?
Container 1 is more dense.
More dense. Okay, right. So basically, in a confined area volume, if more amount of the mass is present, then obviously it will be the more dense. Okay, so and if less amount of the same thing is present, then it is less dense. Okay, so dense means mean how they are spread in particular volume. Okay, so as compared to the other two things, ceramics and polymers, the metals are highly dense. It means they are very compacted. Okay, at a very less space, they are tightly packed. Okay, if they are tightly packed, it means they are more dense. Okay, as compared to ceramics are less packed. Okay, polymers. Okay, so I hope you must have the idea, not just listening the things. You can able to correlate the things. Okay, which will help you understanding the material science. Okay, yeah, okay. So it is the more dense as compared to polymers. Okay. With regard to the mechanical characteristics, these materials are relatively stiff and strong, yet they are ductile. Ductile means they are capable to the large amount of deformation without fracture. Right. So these are the properties. What they are? having the first is the stiffness is high, okay, strong, ductile, okay. Some materials, I mean, if you would categorize according to the your the capability to extension, there the material could be defined into two categories: ductile and brittle. Okay, so some are ductile and some are brittle. So metals are ductile generally, right? What is a ductile means? They are capable of amount of deformation without fracture. I mean, if you will stretch them, they will deform. Okay, but they will not fracture. Fracture is something the material have failed. Though, okay, sometimes the deformation starts that we consider they have failed in material science or in the engineering basically. Okay, so deformation have, if I mean, some deformations are two types. I mean, basically deformations are of two types. Sometimes deformation could be reversed. Okay, the deformation that has been started in material. Okay, if we will lose, I mean, we unload the material, unload the loading, they will come to the original position. Okay, I mean, the deformation that has been placed due to the applied load, and when we remove the load, the material will come to their original position. So they deformed, but they come to their original position. This is known as the deformation, but it's a elastic deformation. Means you are deforming the material, but once the material, the load has removed, the material come to their original position. Okay, so that deformation is allowed. That would not be counted as a deformation in engineering. Okay, but after yield, or after you can say the elastic point, elongation point, after the yield point, you would not be, I mean, you could say the proportionality, once you will, study the Hooke's law, okay, then you will be able to know what is the point where after that point, the material cannot regain their shape. If you have, so no, suppose you have applied the load and you are continuously applying the load, or you have kept the load continuously. So after some times, the material will increase. I mean, the deformation will start. Deformation will get increase, 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 and after some time, they will not be able to come to their original position. Though you have removed the load, okay, but in that condition, the material will not be able to come to their original position. So that deformation is known as a plastic deformation. Okay, but here we are talking about the elastic deformation. So elastic deformation and plastic deformations. Okay, so but here in ductility we are talking about general deformation, right? Okay, so elastic deformations are allowed in engineering, but plastic deformations are not allowed. Once the plastic deformation starts, we consider that the material has failed. Though material has not failed, okay, but in our application, there, according to engineering science, engineering application, they will consider as a failed material. Okay, though they will resist the load as well, and after some times they will fracture, they will crack down. Okay, but mostly in the elastic material, or you can say about the metals, they fail at the fracture. They have the very they could have the more capability to bear the load, but we consider once they cross the yield point, I mean, where they cannot regain their shape. Okay, that will consider as a fail. The material will not fail, material will not break, material will be present there, but they are not for the safe use. Okay, the deformation and an assist to the fracture, right? Fracture means, I mean, obviously, if something is very, stretchable, okay, they can deform, they can resist I mean, they can deform, but they cannot crack, okay. It means they can resist the fracture. Fracture means if the something has broken out in two pieces. Okay, that is not a fracture. Okay, so this is the reason. Okay, this is the reason why the metals is used in many application, many structure applications, because they have the capability not to break, not to fracture. Okay, because if initial they have uh, the deformation, you are able to see that yeah, there is a crack, there is a the deformation is starting, then you can have the time to replace that particular product, and you are basically living in the safe zone, right? That's why it is using I mean metals are used frequently in many structural applications. Okay, so metallic materials have the large numbers of the non-nuclearized electrons. That is, these electrons are not bound to the particular atoms. Many properties of the metals are directly attributed to these electrons. So, in metals, I mean the electron present in orbit, which moves basically, which round in circles. Okay, that defines the properties. Okay, and there the material behavior, how the metal behaves. Okay, the material properties are, they are the good conductor of electricity. Okay, right? Why? Because they have the free electrons in their orbital structures. Okay, that free electrons are responsible to propagate from one, I mean they are responsible to conduct the heat from one to the another. I mean the at the moving electron, which is responsible, who, I mean they transfer the energy to their correspondings, and they will transfer to the nearby. So this is the way how the propagation of heat from one end to the another end in uh, metal is very easily. But in some other like ceramics or some non-metals, which is not possible. Sometimes though are they are possible, but not frequently. Okay, if non-metals you have kept continuously keeping heat, keeping in heat, okay, they will transfer the heat, but not due to the free electrons. They will due to the lattice structure, lattice vibration. Okay, so two terms are basically associated with the conduction. Okay, that we are not going in details right now. Okay, so this is the things. So how why the metals are using being used frequently across the structural parts. This is the main reason. Okay.